Okay, is okay. Good morning, everybody. I see we have some participants to come in. This is great. My name is Qing. I'm the inside sales from Fleetech Netherlands, the Europe team. Well, today let's get ready to welcome Elona Rista, and she's the product support manager at the Solar Turbines. And today she's going to give us some insight on temperature effect on turbine oil degradation and deposit. There you go.
Yeah, thank you so much for the introduction. Definitely. I will warn everybody, it's 2 a.m. in the morning for me, and that's why the windows are so dark behind me. But hopefully you'll find some useful or at least interesting information in the next few slides. So again, the topic today is on temperature effect on turbine oil degradation and deposits. As you know, based on the company that I work for, Solar Turbines, we manufacture gas turbines. You can probably understand why we have such a deep interest in understanding the way that temperature exposure affects the quality of the oil and the rate of degradation, how quickly it degrades and what the results of that degradation are. So without further ado, I want to first introduce the testing protocol. This is the top test, the turbine oil performance prediction test. And we have been using this test protocol in collaboration with Fluitech. So the laboratory where the oils are being tested is the Fluitech lab in New Jersey. And for the past 3 years or so, we have been rapidly aging a whole slew of different turbine oils under controlled laboratory, and the outcomes of that degradation as well. So a quick few words on what the protocol of the test is before we move on to seeing some of the results. So we start out, one of the protocols that we are using is at 120 degrees Celsius. We start out with 4 samples of 350 milliliters that are placed in glass test cells, and also steel and copper catalyst is inserted into the glass tube. This is placed there with the goal to rapidly age the oil or speed up the rate of degradation. And these glass samples are then inserted in a solid temperature bath for the next 12 weeks, where again the temperature is maintained at 120 degrees Celsius. In addition to the catalyst and the temperature, dry atmospheric air is bubbled through the sample as well, again with a goal to speed up the rate of degradation. And out of the 4 cells, we pull out one periodically at different milestones. So we perform an analysis of the oil at time 0, and this is our baseline of the new oil. And then we take a sample after aging the oil for 3 weeks, for 6 weeks, for 9 weeks, and finally the last sample is taken out at 12 weeks. Then, you know, for all these samples, we are testing for all of the degradation parameters that we typically routinely test in the field, and these would be your usual MPC test, RPVOT, and ruler, the TAN or the total acid number, viscosity, and so forth. We have repeated a similar protocol with higher temperatures as well, but we have shortened the exposure time for these higher temperatures. So one test is done at 180 degrees Celsius for 5 days, and another test is done at 195 degrees Celsius for 5 days as well. And in all 3 of these protocols, we are starting with new oil. And so just a quick word here, just to give a baseline of the correlations of temperature to what we believe to be the rate of degradation. And typically, we talk about that rule of thumb of the Arrhenius principle, where roughly the oil degradation rate doubles with a 10 degrees Celsius increase. There was an Consarian user of Louisiana State University, which was proposed, that provides a slightly better. So on the right side of the slide here, you can see based on 65 degrees Celsius, which are the typical header temperature for a gas turbine operation, like what Solar Turbines manufactures. At 180 degrees, the rate of degradation increases drastically. We are looking at a rate of 3,700 times more thermally stressful than the typical.
Hello?
Did I lose you for a minute?
Yes, we just lose you for a couple seconds. So,
Okay.
and then we also lose
Apologies
your
for that.
presentation. Yes.
Okay. Hopefully we're back on, and that was just a one time fluke. My internet. Okay, so the next.
Sorry, Elona, we're also not able to see the presentation page. This.
Share the screen.
Yes, your screen's back on.
Some of the higher temperature conditions are not that uncommon in lubricating systems of gas turbine operations. So we have seen events in the field where high temperature conditions are pretty common, such as in cases of electrostatic discharge, in cases of microdieseling, in cases where there's an oil heater present with poor temperature controls. So the area around the heater tends to degrade the oil, the turbine, the oil passing through some of the hotter sections of the turbo machinery, so especially in the bearings. So again, the situation where the oil is being subjected to higher temperatures is unfortunately fairly common in the operating of a turbine, and especially a gas turbine.
Elona, I'm sorry, just to disturb
Yes.
for a second. Maybe you can just click your video off. So
Okay.
I think that will help with the line go a little more smoothly.
All right, let's do that.
Exactly. Yes. Perfect.
The video does tend to suck up some of the internet, so that's a excellent suggestion. So now moving on to what everybody's waiting for, hopefully, some of the results that we've gotten from the test. And I'll show you here results from 5 different oils, 5 different formulations, and the performance also tends to change drastically from one to the other. So oil 1, full disclosure, this was a full synthetic oil, so it was expected that the performance would be good for this particular oil. And we can see here in the first column, we see the results of the oil analysis at time 0. So this is the oil when it was brand new, and all the parameters are as we would expect them. The total acid number is normal and low. RPVOT is at 100% of the antioxidant level. Viscosity is normal. This is an ISO 46 centistoke viscosity. And then we see the results at 12 weeks. So after we have aged the oil for 12 weeks at 120 degrees Celsius, we see that the oil is still relatively healthy. The tan has not changed much. We see a slight viscosity that hasn't changed. However, we do see a marked increase in the MPC number. We're going from an MPC of 1, which is expected for new oil, to an MPC of 26. So regardless of the antioxidant level still being at a very healthy amount, we are seeing a good amount of varnish precursors building up in the system, as we can see both from the MPC patch, but also in this case, we were very lucky to have a secondary confirmation on that varnish deposition. And that is by looking at the glassware itself, where the oil was aged after dumped out. We could see how much, or we see not just the coloration with the amount of varnish that deposits. As we move on to the higher temperature, the 180 degrees Celsius test, I apologize that I don't have glassware pictures here, but the MPC also tells us a pretty good story. We see to most of the parameters, so the viscosity hasn't changed much. The tan is still very low and normal. Again, very little consumption in the antioxidant amount. However, we still see that the MPC has increased quite a bit. And remember, we are only aging this oil for 5 days at 180 degrees Celsius. So it is a pretty impressive increase in the varnish precursors to see the MPC rising to 46 within the time frame. And then by comparison, again, we're aging the oil at 195 degrees Celsius. So this is only a 15-degree difference from the previous test. And here we see that the viscosity remains normal, but we are seeing an increase in tan, or the acid number. So it goes from negligible to almost 0.4. And while this is still within the acceptable parameters for the Solar Turbines specifications, it is still a concerning increase in that 5-day testing period. In addition to that, we're seeing that the antioxidant numbers are now being consumed at a much higher rate. So we have only about 23% left at the end of this test. And in turn, also the MPC is showing much higher levels. In this case, it was an MPC of 59. And we can also see in this case the visual indication of varnish deposition on the glassware and on the catalyst coil as well. Oil number 2, and this was a mineral-based oil. Again, same exact tests were conducted here with very different results. While the previous test, we did not see much effect aside from an increase in MPC by week 12 of the lower temperature test. Here we are seeing a drastic change in the oil quality overall. So while the viscosity and the tan still remain fairly low at the end of the 12 weeks, we are seeing that the antioxidants are being consumed at a pretty rapid rate. So we are left with 35% at the end of the test. And more impressively, we are seeing a number, as you can see, the MPC is now at 78. And again, the glassware and the catalyst coil deposition also confirm the amount of varnish presence by looking at the amount of deposition present on both of them. A similar result is seen for the 180 degrees Celsius test, where the MPC is, I would say, very similar to the previous test. And then something curious happens at the higher temperature test, 195. This is where we see not only the MPC and the RPBOT dropping, but the other parameters are now starting to shift considerably. We're seeing a sharp increase in viscosity, which from what I have seen in the field, viscosity tends to be a lagging indicator of severe degradation of the oil. And so in this case, we have confirmation that the oil is severely degraded. In addition to that, while this is not very common in the field, I would say that I've seen this in a few cases where we see the MPC dropping unaccountably, so without an explanation. There was no treatment of this oil to explain a lower MPC. What we hypothesize is that in some cases, as the MPC increases with the oil aging, it reaches an inflection point where the amount of deposition increases, but the MPC itself kind of. So as you see from the glassware and the catalyst, the amount of varnish deposition hasn't changed much. If anything, I would say it potentially increased compared to the previous samples. And here's oil 3. So by a little contrast to the previous oil, we can see that for the baseline, again, everything is normal as we would expect it. At 120 degrees Celsius test, the end of the 12 weeks, we see that all the parameters are fairly normal. We have normal viscosity, very low tan, very good retention of the antioxidants, and the MPC is only 8, which for a field sample, that would tell me that the oil is in very good condition. However, and we saw this with this oil in particular and with a few other formulations, the deposition on the glassware is telling us a different story. So this oil was very good at, I would say, hiding the varnish in the system. So the MPC and the amount of deposition are not matching very well. We see that there is quite a bit of varnish depositing on the glassware, while the MPC test is not confirming the same results. As we move on to the 180 degrees Celsius test, this is where we see the MPC actually starting to increase as well, and some drop in the antioxidant level. But in the 195 degrees Celsius test, this is where things actually get exciting, because we see some of the other parameters are moving as well. This is where we see the tan crossing the 0.6 threshold. We see the RPDOT, or the antioxidant level, basically obliterated at this point. There's none left. And we also see a sharp increase in the MPC. So at this point, the MPC has actually caught up to some degree with the actual amount of deposition on the glassware and the coil. And oil number 4. So with this oil, we actually saw very good performance for the majority of the tests. At 120 degrees Celsius test, considerably is consumption in the antioxidant levels. We do see a little increase in the MPC number of 9. However, the deposits on the glassware in this case are almost a field. An oil that has a normal tan, even though it might be consuming the antioxidants at a good rate, it seems to me that those antioxidants are doing an excellent job at protecting the base oil from oxidation and varnish formation. At 180 degrees Celsius test, this is where we see going to increase some. And again, at 195, this is where things get exciting. Again, this is where we see the MPC has increased sharply to 70, with some amount of deposition on the glassware as well, though compared to some of the previous examples, I would say this is a lower amount of deposition. Again, the antioxidants are almost all gone. There seems to be a very common pattern. Antioxidant consumption is at a very high rate. We also see the tan increasing quite a bit at 1.31. And this is where we also see the viscosity starting to shift a little bit. Again, this could well be a lagging indicator of severe degradation of the oil. And lastly, oil 5. These were some, and that I don't want to see this in the field, but for the laboratory, this is actually pretty exciting. For this oil, unfortunately, I do not have the 180 degrees Celsius test, but even with the two tests that we conducted at 120 degrees Celsius and 195 degrees Celsius, we see very sharp changes in the characteristics of the oil. In both cases, we see the tan antioxidants are virtually all gone. And we see the delta E or at very high levels. However, how accurate the MPC is when you have a patch that looks like the two in the picture here, it would be hard, I think, to focus on the particular. But even more impressively, the amount of deposition that we see the actual glassware and the catalyst itself actually tell us a pretty good story and correlate with the odd NPC patches that we see in this case. So what we expect is severe, very severe oil degradation at both of these conditions, even at the lower temperature conditions. For most of the previous oils did not switch, was the weight of the residue. In some previous oils, it wasn't really with you can see it's hash itself. So with all that said, we had a few conclusions based on these tests, and there were enough that I had to split them in two separate slides. Yep.
I'm sorry to cut in. Do you mind to give a very short summary about oil 5, because I think the network, we hardly heard anything about oil 5.
Okay. Yes. Thank you for the heads up. Okay. So can you hear me okay now?
Yes, at the moment it's okay. Yeah. Some of the oil also eat up a little bit, but oil 5 was really almost more than half of them. We didn't hear it. Sorry.
Hopefully the pictures really told the story there as well. But okay, in terms of the conclusions, number one, the oil aging at 120 degrees Celsius, we believe that in field cases, even though in the field we're not aging the oils at 120 degrees consistently, we do believe that the oxidative, the field results that we have gotten, or the routine testing in the field doesn't always depict reality. For example, the oil where the MPC did not match the deposition on the glassware that we were seeing. So MPC might not always be telling us the real story. Also, that accelerated aging at higher temperatures creates new degradation pathways, such as a sharp increase in the acidity, which we have seen in the field, rapid consumption of antioxidants, changes in viscosity, and cases of MPC rising and then dropping as the oil continues to degrade. So again, all of these have been seen in the field. And the last bit of the conclusions here is that not all of the oils are created equal. So the formulation, both of the base oil and of the antioxidants, I believe, makes a big difference in how that oil reacts to various temperature regimes. In terms of ranking or performance, it can change with the temperature. And as you can see here on the right, at the 120 degrees Celsius top test, we have ranked based on the deposition from best on the right to Celsius test. Some of the rankings have swapped. So for example, oil 1 and 4 now have changed places, and same for oil 2 and 3. Another finding is that deposition is actually a very high value measure. For the field, we were able to develop a similar test. Currently, rely on MPC and perhaps on ultracentrifuge testing, but there is no real measurement of the actual amount of varnish that deposits on the system. So I hope somebody is working on a test for this in the future. And lastly, which one is the best oil? Well, it really depends on the application and the operating conditions. One oil that performs really well at 120 degrees might not be the best oil at the higher temperature conditions, as we saw with the rankings here. So the selection of the oil very much depends on the needs and the application for of the end user. Connection, hopefully you can still hear me, and we still have a little bit of time for questions.
Hello, Elona,
Can you still hear me?
Oh, yes, I
Yes.
think we just lost you for a minute.
Can you hear me?
Yes, we can hear you.
Okay. Well, hopefully, again, the information on the screen is clear enough.
Yes, that's definitely. The picture does show, yeah, does show us some a good deal. So,
well, if there are any questions, I'll gladly take them. I think, again, apologize for the unstable connection. Can you still?
hello, Elona?
Yep. Yes. Can you still hear me?
Okay, well, yes, at this at this second, yes, we do. But I think it's better I just end this session because
Okay.
yeah, due to the network. Yeah, well, if anybody has questions, they're able to reach Ilona. And then thank you very much for this fantastic presentations. And then also have a very nice day to everybody who's attending this session. And then we will just say goodbye for the moment.
Yes, thank you so much for the opportunity to present, and apologies for the instability of the connection, but there's always the recording from my previous presentation at the Americas session.
Okay, done. Bye, everybody.